your layers through your destination, through your the process, the pipeline transformation processes to the destination. Your math layer also acts as a destination because your math layer is the query table, right? Is the presentation table. Is a table where you can give the end users, the analysts and whatnot, to query whatever they want from that table, right? And then your BI layer is also a layer above math, right? So it is still also a destination, but as you can see, it's a more defined destination. So you have the clear metrics defined in that layer. You have paid versus zero daily. Probably there's a definition for that, right? There's supposed to be a schema dot, what do they call that, schema dot YML file to explain all these models, right? So you would have those schemas here. You have something like this to explain the model to the end users who wants to pick this, to get let them know what this table is talking about, right? So BI is just a layer above that, right? And in your modeling, in your transformation, in at an industrial level, there can be multiple levels of these layers, right? There can not only can there be multiple levels vertically, is yeah, vertically, so that is upward. So vertically you have in this case you have, let me see, you have staging, you have intermediate, you have maths, so they are like on top each other, right? But you can also have it horizontally, so you may have maths, but not only maths, you may have maths to the marketing team, so maybe maths marketing. You may also have maths finance. You may also have maths operations, right? It's still the same maths, but at a vertical level for different teams, right? So all this makes different use cases and different applications for pipelines, right? So that is a very good thing to understand. This is a very basic level. So what I just said now is a very basic level. If you're going into the markets, if you're going into the um, labor market with this knowledge, you'll just look at it like, okay, everybody literally knows what you're talking about. So it's not like you know something, but you still need more knowledge to accompany this. This part here, so cost efficient incremental processing. Right? It basically just increment. Oh my god, I've taken light. Oh, it's basically still incremental models. So now the question is, what are incremental models? So let me. So the concept of incremental models has to do with um, what do they call it? The way your pipeline is being run and your data is being processed, right? So it has to do with the way your tables actually are being processed. So what that means is when you perform a DBT run, so when you do DBT run on your project, what your project does is it reloads all the data in your source, right? So in this case you have data in your data warehouse, right? The moment you do dbt run from that your raw layer, it performs the series of transformation that you built out. So it performs the staging, it performs the intermediate down to the math, right? It performs this series of transformation on all the data in your raw, excuse me, in your raw layer. So incremental models or incremental processing are just like strategies. It's a strategy in your sorry. So what incremental processing does is that it tells DBT, right, that when you run this model, when you run this data, you don't want to run everything inside your source, right? So imagine, for example, you have a set of data in your source, right? Um, every every transaction that happened today or yesterday, yes, every transaction that happened yesterday is inside your source, and then you did your DBT run, and then it processed every data inside there to down to your destination, so down to your math layer, and then today came, transactions were also done today. Now, your regular DBT project, if you do DBT run, both the transactions of yesterday and today, because everything are inside your source, both of them would be processed again into your destination. And that is not efficient, right? That is not ideal in any way. The purpose of incremental model is the moment your model is incremental, it's going to process only your data, only your latest data, which is your data for today that has not yet been processed into your destination. So it's not going to reload the one for it's not going to reload the one of yesterday, right? In this case now you can see here you have a full refresh. So full refresh means it's going to refresh everything from your source data, everything from your source data into your output, into your destination, right? But incremental runs, it simply means only the new data should be processed and be inserted into our tables, right? Into our destination tables. That is the whole point. That is the whole conceptual explanation of what incremental models are, right? So if you have any question, let me know if I've been able to explain incremental models properly, incremental processing properly, and then I will showcase how it was done in the project. So far, so good. If you have any question, let me know.
I understand. So if I just to reiterate what you have said, so incremental project processes are, those processes that do, let's just say, n minus one, meaning by n minus one, I mean removing the previous day's transaction and working on the latest or the current transaction, which are also data and runs that to our destination, which happens to be our output model. So incremental model does not perform like a full refresh, and it does not process in our source, which is our where our source data is. It does it in the model itself and gets it to the output, right? Am I?
Okay, so the idea where you said it does not do it in your source. Remember, all data comes from your source and only passes through your models, right, down to the destination. Your destination is your maths layer and your BI layer, like I said. So the data is in your source. That is where it's picking your new data from. And yes, it picks only the new data. So in an incremental process, it's going to pick only this one. But in a full refresh, it's going to pick everything that already exists inside your data, inside your source table. So that is the idea of incremental. Let me see, Mr. Fatai.
I'm sorry, I did not get it very well. Oh.
Okay, is it like trying to run something gradually? Close enough, close enough, but you're only running. Okay. Let me tell you what it is. You're only running data that has not been run, that has not been run. Which kind of English am I using right now? You're only running the new data in your source for incremental models. That is all it is. You're only processing the new data in your source to your destination. If it wasn't an incremental model, both the new, the old, everything would be processed. But for incremental model, it is specified that run only this new one that just came in. Why? Because this previous data, this one here, it has already been processed before and it is inside your destination, right? It's inside your math table. So there's no point processing it again. That is waste of resource. So process only this new guy, only this new one over here, and then insert it into our table. Okay, so Mr. Fatai, does that answer you? Okay, so I hope that also answers Mr. Sean. So in this case now, I want to sorry, Mr. Fatai, I don't know if you were able to do the rest of the project. I don't know where I stopped with you. It's very hard to keep up with where I stopped with you. If you're able to go far further in the project from where I stopped with you last. Okay, so where did you stop? But I'd still like to know where you stopped. Let me have an idea. Okay, so let's go on. I don't know what the last class is now. Let's go on. This okay. So this is our incremental model. hmm Another question is um how do we now set an incremental model in DBT, and which of our models should be an incremental model, because you can't make everything an incremental model. Right? You can't make all your tables or all your layers incremental. You are only select few that you have to pick. So the rule of thumb here is the simplest rule of thumb that I'll give you guys is to make your fact tables incrementals, right? So your fact tables are transactional tables. Now, this is a very simplified version. There's more better way to explain it, but a rule of thumb you can just follow is make your fact tables incremental. And why is that? Remember, I said your fact tables are transactional tables, right? They are the ones that hold all the events, the records of events that are happening in the business. So in this case, the fact table here is facts trip taxes. So it's holding the trips, right? It's holding the records of the trips that were actually made. And so these trip records could be often. It could be very, it's the main event that happens, and it's a table that could be growing consistently over time. So that is why you put this fact table as an incremental table, right? So you're able to always process new trips that are always happening in batches or over time as often as you run your model, right? So that is the rule of thumb in selecting your incremental model. You don't put every model as an incremental model. So how do we configure this incremental model? In our model, we have this block at the top. So you would have config materialize equals to incremental, right? This is what tells DBT that you want this model to be an incremental model, and it comes with a unique key, right? The unique key is a unique key from your table. So in this case, strip sk is a unique key here. Then you now have you now in, down here you now have this block of code. You now have this block of code. This is a macro in DBT, right? This macro tells DBT that okay, I want this. You've already told DBT up here that you want this model to be incremental. So which now DBT wants to know what what column, right? What column in this table can it use to identify which data is a new data and which one is the old one. And to identify that difference, you're definitely going to need a timestamp, right? A timestamp column, right? To indicate that okay, this was the last data that was processed. Anything after this is a new one, and you would use the time it was processed to tell that. Now, in this case, you can see I'm using trip dates. Trip dates is a timestamp column. What does trip dates tells us? Trip dates tells us the date the trip happened, right? If you check the table, you see is a date, and trip dates is the date the trip happened. So now imagine you run your model for all the trips that happened yesterday. Obviously, today's date would indicate that is a new data. Any trip that has a date after yesterday will tell the model that okay, this is a new data. You want to process this data, right? So it simply says use trip dates. Forget all this extra code here. It simply just says use trip dates, use trip dates as the column to check for, for incrementing your data. That's the purpose of this whole long macro down here. So we won't go into explanation of this yet, but that is the purpose of this, right? So, and then this is okay, this is the rest of your model. So, like I said, configuration for telling DBT. This model is an incremental model, and this macro down here for telling DBT. Okay, it is trip dates I want to use to check for the latest data or the new data that just arrived. Okay, so that is honestly that's about. But if you notice, I'm just trying to simplify it as much as possible. There are more elaborate explanations, but this is the simplest way I want to go with. And then next in our project, in our models, we have what we call snapshots. In our models, we have what we call snapshots. In DBT, you would see column there snapshots. So snapshots are basically to capture slowly changing dimensions. Hold on 1 minute. Snapshots are to capture basically slowly changing dimensions. At least that is one of their obvious purpose. The question now is what are slowly changing dimensions? In your project, you have in your maths you obviously see fact tables and then dimension tables, right? Slowly changing dimensions are dimensions that change slowly. What does that grammar mean? Like I said, your transactional tables have transactions happening all the time, right? These are not slow stuff. These are not things that happen often. They happen frequently, as often as possible. But slowly changing dimensions, the idea of slowly changing dimensions is you may have a table that rarely changes, so your dimension tables are records, but these records may not really change like that. But not only do they barely change, but you also want to have the records. You also want to have records of the old data and the new data. When I mentioned so incremental and snapshots, when you're just starting out, it sounds similar, it sounds alike, but there are differences, right? So when I mentioned facts tables, incremental processing, I only said it processes new data into the existing data. So it's just literally adding all the new data inside. Why is that? It's because each of those records are basically unique records, right? If you take a trip today and you take a trip tomorrow, those are two different trips, never the same trip. That is why those are even transactional tables. But in your dimension table now, you could have a dimension for customers. Now, your customer is going to exist in that table, and that your customer can take multiple trips. Doesn't mean that you will store that customer multiple times in that your dimension table. No, you only have a single record of him. Now, in this record, in this dimension table, you could have, I don't have customer here. Wow. In this dimension table for customer, you could have the customer telephone number, you could have the customer address, you could probably have the customer maybe card number or something. But I don't know if they store card numbers in databases, but that's just an example. So now you could have this information about your customer, and you could even have your customer name. But notice that the customer address, your address is not something that changes often. but still likely to change regardless. Right? Today you can be living in Lagos and tomorrow you move down to Abuja, or next tomorrow you move down to who knows, Kaduna or somewhere. Right? Now what snapshots tries to do is snapshots tries to capture all those historical data. So it wants to make sure that anytime you change your address, it stores that record. So there's always going to be duplicates record. If you change your address and you travel to Benin Republic, it's to keep a record of when you were in Nigeria, of your address in Nigeria, and it's going to keep a new record of when you were when as you are now in Benin Republic. Benin Republic, right? If you travel again and you move to Ghana, it's going to keep that record of your address in data in Ghana, but obviously it's going to be a new record. It is not going to replace the historical data, which is your address in Nigeria. It is not going to replace that one. It's going to create a new one entirely. Now, why are we even creating a new one? It's because we always want to have historical reference to your previous data. You always want to have reference to the historical data. So you want to have a record of all the transactions he made when he was in Nigeria, or all the transactions he made when he moved to Lagos, or all the transactions he made when he moved to Abuja. You always want to have that record. If you don't, and he traveled to USA, and you say no, you made a transaction when you were in Nigeria, and you have no proof, you can literally say he was not in Nigeria. He never lived in Nigeria. He's not even Nigerian himself, right? So that's the idea of historical data and slowly changing dimensions. You could change your phone number tomorrow, but doesn't mean you change your phone number every time. These are slowly changing records. Hence the name slowly changing dimensions, right? And slowly snapshots exist to capture those historical values. So that is why in your project you have a snapshot table. So here shots for dim location, right? Our example will be snapshots for our dimension of customer, so dim customer, so that anytime a customer changes something, all his records all his records would still be stored in this model. And this is even supposed, let me see, snapshots, dim location, targets, unique keys, strategic. Okay, this is a table. So all historical records will be stored in this table. And then now if you see this maths, you also have a dim location. So why do we have dim location here and a snapshot for dim location? So one, this snapshots dim location stores all your historical data, right? It stores historical data for all the customers. But this dim location, why am I even saying location? But please bear with me. Example is customers. But now, say here you have a dim customer. This dim customer is, like I said, your maths layer is the presentation layer, is the layer that the end users will be using. So they are not going to be requesting for historical data all the time. They are only going to need the latest information about your customers. That is the purpose of this dim location inside here, inside your maths layer, right? Now, if tomorrow they want to find out historical data about a single customer, they can now go and query this snapshots dim location table. So please note that snapshots is majorly for storing historical data and slowly changing dimensions, while incremental models are to simply update your transactional model with your transactional table with new data that was recorded into. Honestly, writing and reading this will be better, but update your transactional table with new data that is inside your source, right? So these two concepts, incremental models and snapshots are, very important concepts that you should know at the back of your head, right? So at the back of your hand, how do you put it, right? That you should just know when you hear them. So when you hear incremental model, you know this. When you hear snapshots model, you should know this is it, right? It's not exactly game changing knowledge. It's just foundational knowledge that you should be aware of, and you should know and know how to implement these two things. So over here we have our regular snapshots, right? Our snapshot simply stores all everything inside, everything from our source. Okay, this was where I made a mistake. Yep, this was where I made a mistake. So I was calling dim location table. So Mr. Sean, if you check your own, ChatGPT probably corrected this for you, and it's corrected the one inside dim location for you. So inside here, I'm calling dim location, which is not supposed to be, right. I can't be calling the model snapshot is supposed to be feeding, right. So this reference is supposed to be a source table, which should be intermediate. Intermediate, or does it mean maths represents incremental model? So yes, so maths are incremental. Your facts table is inside your maths, right? And the reason why your maths are incremental tables is because if you look at your code, if you look at my code, if yours is not ready, if you check intermediate, just look at this intermediate. Let me check my DBT project. So if you look at this is your staging layer. So our staging is materialized as a view. Our intermediate is materialized as a view, but our math is materialized as a table. Now, why is that? It simply means that these two models, right? Even if you run your model, even if you run your DBT run, because they are views, right? The data inside will not persist. It's just saying do this and return the data. The moment the data is being returned, that's the end of it, right? It doesn't exist again. But now in your maths, this model is a table. It simply means when you run your model, everything is saved in your data warehouse as a table. It records it, it keeps the record. So from your source now, you're obviously going to have data that is in your source that is not in your maths table. But you cannot have data that is in your source that is not in your staging table, because this staging literally does not exist. It's just a view. It's just a pipeline for data to pass. You're not storing data there. You're just telling it pass through here. That is it. Intermediate, the same thing. Pass through here. Nothing is being stored here. So it's from your maths layer that I can see, okay, all your data, everything that you've processed through here and through here, the processed data is being stored here. Okay, now check this table for what was the last data that was inside. It will not check. It will not say, okay, process the new one and insert it inside this table. So yes, your incremental model is literally done in your facts tables, in your fact table here. So that is it. And then with your snapshots also, if you check snapshots, if you see this your dim dimensions model also, your dimensions are, why did I do this as a view? This is wrong. What is doing me? Let me see. Dimensions supposed to be table, not even view. Please, Mr. Sule, Mr. Sean, I don't know what I was doing while I was doing this particular.
I get.
I don't know what I was doing when I was doing this particular model, right? This is supposed to be a table, because this is
Maybe
where
you were tired.
oh God. Yeah, because this is where your records for customers are being stored, right? So it's literally, so this config blog is not even supposed to be here because it's already here, right? So the moment, if you have this here,
If I miss, I have question for you. Check your chat.
okay, Peter, have you guys done? I was asking you now. Mr. Sharon has done it, right? He did it. He did like most of them by himself through the help of ChatGPT. So that is the thing. So I did it. I did it for. We did it together to a point, and then he did the rest. So even if we've not gone far with you, Mr. Fatah, I can just show you this and this. Then you try and figure out the rest. So that is it. Um, this block of code is not supposed to be here, so I'll try and polish all these things. Okay, so I can see you can see in this one now that we have a dim location current. So I was probably experimenting, and this dim location current is for all your data from snapshots, but the most current version, the present version, not the all the historical one, just the most current one. So you can see we are getting our source from, we are referencing snap dim location. And then if you notice, the mistake I made here was from snap dim location, I'm referencing dim location, which is wrong, right? I'm supposed to reference, probably I'm supposed to reference, where is it? Which one am I supposed to reference? I'm supposed to reference staging location or something location. I sure know I'm supposed to reference something else. I'll check it again. But it's not supposed to be dim location. Maybe I was referencing dim location because I didn't even set up what to reference here. But that should have been done. So just above all, forgive my mistakes. Above all, just understand the concept of incrementals and snapshots, right? All this can always be corrected. So any question, any extra questions so far?
Makes sense for me. No question. I understand everything. Just ensure that this video is important to us for explanation because you are giving like detailed explanation to every process. So at the end of the class, I will need the video ASAP
No
to go over
wahala,
it again.
no wahala. Just go. There's one guy. There's one guy's video that I used to watch anytime I want to understand all these concepts. So is this one? Let me see if I'll see him. So is this guy's video here? Kahan Data Solutions, right? So very straightforward. Is it Bara? No, Bara's own is more of data engineering, right? This
Just
guy,
share us the link. Just share us the link of the guy, current data solution.
okay.
Just share us the link so that
So Bara is good for learning data engineering itself, right? But this guy, anything DBT, just go to him, right? Because DBT on his own does not have much materials on YouTube. You will see one or two, but they just have Azia on YouTube. Okay, so I've covered those two, and I covered those two really early. Um, on your own now, Mr. Fatai, probably before the end of the class, I'll need to. God, I said before the end of the class, but they've taken lights, and my battery will probably last 30 minutes, if not less, with all these apps that I've opened, and I'm even screen recording again. Okay, so let me see what else. Data quality enforcement, canonical data models. We have about 15 minutes left. So honestly, I'm open to questions right now. I'm just seeing what I can. I'm open to any sort of, you know, anything beyond this, right? To just ask. I'm just seeing what I can walk through next. Now, so far so good. Mr. Shun has technically completed the entire project. As he has run it, it has established in his data warehouse. The last thing we might want to do might be to add your BI, add your models into Metabase, right? So that you can get a feel of how does your BI data, you know, um, end users made use of it. and that is
Yeah.
probably
I was about saying that. I
mm,
just wanted you to land. That was where, but again, if Mr. Fatah has any question, we have to bring him up to speed. But I was about saying that I think the next one is visualization for me now, which I need to learn. Yeah.
yeah. So now that one I will take in next class, in this evening's class, right? I don't know if you'll be able to make it. If you can, please, I'll really appreciate it too. Like it's really helped me like crazy, right? If you meet this evening class, literally the four of you are on the same page, right? If you meet this evening's class, even if for 1 hour or so, the four of you are basically going to be on the same page. Then I'll take the lady on a separate schedule since she will not be able to make it. So I'll go through this. This we stopped at us, me and the present ones. You're even going slightly ahead of them. Me and the present guys stopped at this incremental models and snapshots. So I guess I can, Mr. Fatai, we would we will try and work it out. I need so what he will do is if there's lights, as soon as they bring lights, I would update, I'll polish this wrong stuff I did, and then I'll commit it back to my repository. Then your own aspect is literally just as simple as still copying and pasting, right? Copying and pasting, and then doing dbt run. Or try and fix all those mistakes, and then once you do dbt run, it will solve your anything you walk through. It will solve it for you. Now, the only thing you need to consider is the snapshots that is inside there. So you just do dbt snapshots and it will run that before you now do dbt run, right? Once you're starting, if you're as we are starting out, we are doing all this dbt run, dbt clinical, bit by bit. But can you also help me with organizing all our videos? Okay. So the next thing now is Mr. Sean, please your state
Yes. I will
your
say,
snapshots, yeah, your snapshots. I would like to see what um ChatGPT told
what
you
is
to
there?
do. Yeah, so I'd just like to see what I can correct it. It's not like
Okay.
mm,
Let me share my screen. There.
so Mr. Fatai, what matters now is all this explanation you've heard. The practical parts, you can just we've already gone through the practical aspect of building your model in that first project that we did, right? That's why that first one is very important. So after that, it's literally just copy and paste and understanding the concepts behind it.
So this is the snapshot, the snap dim location, which is
Okay.
under the snapshot model.
Okay.
So so this is what I have there.
So it's
So
corrected. So
this is the reference you
it
are trying to
removes
say
staging, taxi, zone,
from,
geometry.
yeah.
Okay. So mine was from the other one. So I'll get all these things corrected.
So which other one do you want me to project?
Yeah, I think that should be good. I've already seen the dim location.
Okay.
Mm. So I
So
guess
another thing I observed from was it this place? Yeah. So
mm,
for me, I could see that you here under the DBT project YML,
mm,
your own is more like, let's say this one is organized also. Your own is more detailed, exactly. So I can see staging materialized schema, then
mm.
also intermediate materialized schema view, then mass in table. So it doesn't mean that I can also add those things here, then it will still run.
No, you can't. You should, right? It should be added.
Okay, okay.
Because if you don't
Because
add,
part of the challenge I faced was some before I eventually corrected everything was that I discovered that at some point this particular DBT project .yml was read with the
mm,
transform. So I kept on putting removing. So at the end, I didn't put anything on the cloud run. The whole project ran.
mm,
So now I'm asking. By the time I say I should put it, that I should have it there.
mm.
So hope it won't affect the whole project.
No, it won't affect. You should have it there.
It shouldn't affect. Okay, I'll do that. Maybe after I'll do that.
You should have it there.
So that's all for my part.
Okay. Okay, so let me quickly share my screen and then go through. There should be one more thing, which is the test. Please, guys, um, data quality enforcement. So basically, data quality enforcement is literally just testing your models to ensure they meet certain criteria. You don't want to just push off any form of data to your end users to make use of, right? You want to make sure particular tables, particular columns have don't have nulls or duplicate values, or one thing is not in them, right? So in this case now we have two types of tests. We have generic tests in DBT and we have custom tests. So generic tests are tests that you would see inside your schema.yml. Generic tests are simply built-in default tests that you can attach, you can put on a column. Now in this case, I have trip sk. Now trip sk from our model is an identifier, right? And if you know, if a feature of identifier is you want all those numbers to be unique. Now if you send data to your end users and they see there's trip sk duplicate strip SK, it simply means that something is wrong with that data, right? So you would want to add a certain test to this model to check if this test is going to pass or if it is going to fail, right? And for generic test, which is inbuilt test, in your schema.yml file, you can just add your model. In this case, I have intermediate taxi trips, and then under intermediate taxi trips, I have the column trip sk. Now, so this is literally this is arrangement of .yml file, right? So .yml file is just a more readable version of JSON files, right? It's literally JSON without curly braces. So you now have name, intermediate taxi trips, then the description, and then under this model, which is this one, you now have the columns. So I have trip sk column, and for my test I want to make sure there's no null inside, and it is unique, right? So no nulls and it is unique. There are other tests like accepted values. So the arguments under accepted values means this column should contain only these two values. Anything other than this should raise an error. So in this case, you have green and yellow. Only these two values should be here. In this case now, you have what? Vendor ID, test, not null. Simply there should be no nulls inside. Now, it also have a severity config. This the severity config means that in this case now it is 1. So it simply means raise an error but don't stop my code, right? Raise an error but don't stop my code. Just warn me that okay, there are nulls in these columns, but let everything run. Because the moment you run your tests or you run your code, you do dbt run, and any test fails, right? That model fails to run, it would not run again. But the moment now you say one, you say okay, run your model but show me a warning, right? So this is the idea of generic models. There are about four dbt generic models. Is my okay recording is still on? There are about four generic dbt models, so let me check for them. Generic dbt test. So, and there's not null, there's unique, add data test, write custom, no, not custom, generic test. Why? Okay, let me go back before my laptop shuts down. And then, so these are generic tests, right? Inbuilt tests. Then you now have custom tests, which you can write in your test folder, right? Mr. Sharon, you could also check for this in the project. So custom test as the name implies is just test that you customize for a particular model. It could be simple or it could be complex, because your generic test is not going to capture all the tests you want to run, right? So an example of custom test here is pickup dates must be greater than drop off dates, right? So what's pickup date? Pickup date is earlier. Okay, not pickup date must be greater. So in this case now, if it checks, this test is saying we are going to check your entire model, right? There's a way it uses test in reverse. We are going to check your entire model, and if this test runs, if you're testing this test run, it should not return anything, right? If it returns something, it simply means your test has failed. So in this case, you cannot have a pickup date. You can't have a trip with a pickup date that is greater than a drop off date. You can't be picked up by 9 o'clock and be dropped off by 8 o'clock. It's never going to happen. Right. So this is an example of custom tests that you would not have available in generic tests. So where are we? Unique, not no. There are two others. There are two others, but this is literally the most popular of the four. Unique and not known is the most popular of the four that you often see. Okay, unique, not known, accepted values and relationship. I guess that is all. I guess that is all, but I will still confirm. I think there are other two. So this is the idea of tests, right? Both custom tests and unique and generic tests. And tests, is just for ensuring, is one of the biggest things in data pipelines for ensuring data quality.